to solve this. We could try factoring, but the problem is even though we have perfect squares, we have a positive number in between, so we're not going to be able to do that. But what we can do is we can solve by extracting the roots. So we get x squared equals negative 16. And then remember, when you take the square root of both sides, you need to do plus or minus. All right, but then here's what's happening here. This root 16 is really the same thing as root negative 1 times 16, which is the same thing as the square root of 1 times the square root of 16. Well, root 16 is 4, but the square root of 1 is I. So again, you probably remember this from Algebra 2, but anytime you have the square root of a negative number, take the square root of the number, and then you would have an I that goes with it. So this is plus or minus 4I. For this one, it looks like this is not going to be factorable, so what we need to do is a quadratic formula. So we have A, B, C. You can also solve by completing the square if you want to, but for this one we have the x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, which is 1 here, all over 2 times a. And so that's going to be negative 6 plus or minus the square root of 36 minus 40 all over 20. But 36 minus 40 is root negative 4 over 20. So this equals negative 6 plus or minus the square root of 4 is 2, but with the negative we need to add the I all over 20. All right, now this is going to be able to reduce. So my suggestion is always to factor the top. So we have a 6 and a 2, so the GCF of that is going to be 2. So we get 2 times negative 3 plus or minus I over 20. But then the 2 and the 20 reduces to 1/10. And then the other thing we want to do is if we're really putting this in standard form, we need an A term, so your real term, and an imaginary term, so the BI. So this is going to look like negative 3 over 10 plus or minus I over 10. So you may have to split those up, especially on Math Excel. They may require you to do that. And then x cubed minus 8. The first instinct for most people is to add the 8 and take the cube root and be like, oh, x can be 2. And that is in fact correct, and 2 is the only real number solution. However, when you're doing complex numbers, when you're solving along the complex numbers or imaginary numbers, you can get all the solutions. So you see how this is x squared? There are 2 solutions always. The thing is here, both of them are not real. Here, there's also 2 solutions in not real. So the thing about this x cubed, there are 3 solutions. It's just they aren't all real. It's going to turn out in this case 1 is real and 2 are not. So the thing is, if we add 8 and cube both sides, you're not going to get all 3 solutions. You're only going to get the real solution. So what we need to do instead is factor. So if you guys remember SOP, okay, and the cube root of x is x times x times x. Cube root of 8 is 2 times 2 times 2. So here's going to be our first term, our second term, our third term. All right, so if you recall, we have x and 2, and then x squared, 2x, 4, and same opposite positive sign. So we have minus, so same sign, opposite sign, and then always positive, that last guy. So one of our solutions is x, this is 0, so x equals 2 by the zero product property, but for this one we can't factor this, so we have to use a quadratic formula. So we have our A, B, C, so I have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then this becomes, kind of moving it up here, negative 2 plus or minus the square root of 4 minus 16 over 2. So that's negative 2 plus or minus root negative 12 over 2, but root 12 is 2 root 3. So this becomes negative 2 plus or minus, and then the negative here gives me an I. So this is 2I root positive 3 now. So I brought the negative out and made that I over 2. Factor the top, so we can pull out a 2 and we get negative 1 plus or minus I root 3 all over 2. Those cancel out. So then you're left with negative 1 plus or minus I root 3.